Okay.
The goal of this video is to explain the strangeness of quantum mechanics by talking about Bell's inequality. Since there's so much justifiable confusion around this, I'll try to go slowly and use as little math and as few technical terms as possible. Still, if I do mention something with the name, I'll try to put it on the screen in purple.
It seems like he knows what he's doing. Covered the 3D, 1D stuff for me.
In the first, we'll look at the experiments that lead us to these conclusions.
Golan's coming up.
Then, in a second, we'll discuss the three options that these experiments leave us with. We must choose one, and each is more disturbing than the last.
When somebody says something about Lebromian, you drop Bells into it and see where they're standing. Are you the teacher or they the teacher? Do they understand that you're supposed to be the teacher or not the teacher inside of here? Because then you'd be in the assisting role in inequality to the position while maintaining the proper charge. So if you're running my parallel,
spin up if the particle goes with the axis, even if it's down on the screen. In this video,
for him, he's going to go that 3D 180 stuff that makes it faith, money, value, marginal utilitarian for me to say yes. I got to carry that diamond, that one there, and
through spatially distant measurement devices. Further suppose that these two particles satisfy some experimental facts. First, whenever we measure them along the same axis, we find that they have the same spin. This means they always either both go up or both go down.
So he's going to get going, but there's more to it than just being able to pick that. This is a level 10 sleeper cell challenge lock.
Second,
okay, there's a double split core, dual pin, spool pin, 6 pin with a modified keyway. The Bible, the Paul, the system. These are a boron shackle, which was a natural advantage to anything that I could do to the housing or geometry that would make it more of a challenge. Given the size, the catch, whatever it is, bump it up on that. We never really talk, we just
along the A-axis.
TCB, bust somebody's ass about.
And down along the B-axis.
No homo. Every bolt.
I should mention that there aren't real particles that satisfy these facts exactly, but they're useful stepping stones because they're significantly simpler than the real facts that we'll talk about in a moment, and they still contain most of the interesting physics.
Thermodynamics, all life in the universe will eventually come on contradiction. Where am I?
First, the particle spins exist independently of measurement. Taking the last example, this means that there really is a particle that has the property of being spin up along.
So how do you take down a warrant officer? By taking out a Sarge Mage in terms of minimum save for flight.
The spin of the particle filled being spin up.
Pregnant woman with a C in a flight suit out the C-17.
Is that the axis we choose to measure particle 1 along doesn't affect the properties of particle 2. Yeah. Now let's reach a contradiction. Recall that we're
talking about moon landing. I think that's what that one is. One of them was somebody says something about, oh yeah, okay, I've flags inside here. The vacuum is real extremist inside of here. 33, the number 55, anti-meme. Something you can't ever really math, but you can math it because that's what that is. It's a pain in the ass. It's some 42, 079 stuff going on in the background. It's like, you can deal with so much.
Will have to be up along B and down along A and C.
Well, you'd say things about, that'll be a problem later when it's like, oh, I gotta have it now come winter. I don't need you no more. You got too many
down. Then we know that particle 2 must be down along B.
So market cap via Apple is one of TikTok one I saw clicking through. In the getting to the point of, what is it, locksmithing?
Now we've reached our contradiction. If right. Particle 1 along the A-axis.
Okay, so the market cap inside of here for Apple is a better number than the price tag of Tesla at $100 or whatever they're doing. And then of course you got to figure Google splitting shares or an Apple 20-to-1 split.
Affects the properties of particle 2. Contradicting our second assumption.
Crazy out here, crazy. Crypto last resort.
Now we move on to the real experimental results. First, though, note
so you
that
use
if
my work, huh?
You're gonna come along each axis, then at least 2 of those spins must be the same. Let's look at a few examples.
Why? Well, I don't really know the perception of what you're looking at the Andromeda paradox here on the orchard. You know what I mean? It's like, I can tell you from here, we will have CT paradoxes that is this
If a
road to
particle
go
is
to
down
the
along
Chinese
every
restaurant,
axis,
you will
then
one
every
way or
pair
the
of
other here,
spins
left
is
hand or
the
right
same.
hand. But you might
No
live
matter
up
what,
here on the
there's
angle
always
of
at least one
45,
pair of spins that are the
as
same.
far as anything's concerned, there's going to be
Since
X.
there's only
Really.
3 ways to choose a pair of spins, this means that at least
Measure.
1/3 of the choices are the same.
Well,
Looking at the first example, the pair A and B are different.
well, now they're in a state where
Pair
they're X
B
and
and
Y,
C
F1
are
plus
the same,
F2 in an algorithm
and pair
where
A and C
you're still
are
looking
different.
at it like it's the
We see
measurement of
that
probability.
1/3
We'll
of the
catch the
pairs are the
IQ
same.
test inside of there about which
No matter the
state
state of the particle, at least
really
1/3 of the
covers
choices of pairs
any one of these
spins will always
50%.
be
You
the
should
same.
be alright. It's going to be more of a
In
narrative
reality,
here, or
there are
something else I'm
particles that
missing than a
satisfy these
fixed
facts
answer.
exactly.
Those are not
There are particles that have the
fixed
same
stock
spin
sets,
measured along
right? They're
different
like,
axes,
oh, well,
one
it's this,
order
and the
of a
PE ratio is that, and
People have done
therefore,
many
no,
experiments
that
on
is an
electrons
important
and
part,
photons
X
that
to
satisfy
Y,
these
in the
experimental
measurement
facts
value
exactly.
inside of there. I need to be here.
Using
It
the
is
first
that. I
assumption,
can't.
we
And
can
I'm just
drop the
narrowing it down,
animation
cutting it in
measuring
half, cutting it
devices,
in half,
and
cutting
just
it in
let the
half
squares
till
on
I
the
have the
left
Planck
denote the
length.
spins of
Some
particle 1,
measurement of what
and the
it's
squares on the
doing,
right
and
denote
until
the
I
spins
hear
of
some
particle
Tweety
2.
bird, some
Suppose we measure
clickety
particle 1
crunchety
along the a-axis.
getting out of here.
Then, by the first fact, if we measure
What else we got?
particle
Just
2
finish it
along
off
the
here.
a-axis, we'll get the same result. By assumption 2, even if we
Pizza
measure
pie.
particle 2
Yeah,
along the
toppings.
b-axis,
Sprinkle
the
factor,
spin along
really,
the
honestly.
a-axis won't change.
Should we just
By our second fact, property
put
A
this
of
here?
particle 1 is the same